Okay, we're going to pick up where we left off last time in 6.2. And we had left off having just sort of talked about some of the mixed number issues, adding and subtracting with mixed numbers, both looking at it from leaving it in mixed number part for at least part of the problem, and also changing it to improper fractions. And the last thing that we're going to take a look at in this section is something called convenient fractions. So this is estimation. Let me kind of make that clear as we get started. Because it's estimation, that means that your estimation and my estimation might not be the same. They shouldn't be drastically off, or then some of us have got some problems. I mean, like, obviously, if we estimate far off, then that's not helpful. But the idea is that if we use a convenient fraction in our estimation, it makes the calculations that we're trying to do, whether they're in our head or on paper, easier to work with. So fractions that are roughly equal to what we're given, but easier to work with, are things that are like these. This list is not like an exhaustive list. Like, for instance, 1/10 is a pretty convenient fraction sometimes to use. It's not on my list. But if it's the fraction that makes the most sense to use, we use it. It's no big deal. Some of the questions that it asks you in your book will tell you to estimate it to one of these 4 specific convenient fractions. Well, that means they really do want you to use one of those 4. It's like multiple choice, okay? So use the one that's most appropriate from the list they give you, kind of things. But if you're not told what to use, then you get to choose what makes the most sense to you. So these are some of the convenient fractions that we might, in fact, use. So we're going to do a little bit of a chance to estimate with a couple of fractions. The fractions are 12/78 and then 2/1001. All right, so if you're taking a look at 12/78, what might you decide that the estimate would be, or what might you decide a good estimate would be?
1/8.
Okay, where did you get 1/8, Andrew? You were awfully quick with that.
I was just looking at it. So I just estimated 12 at 10 and 78 at 80. Remove the zeros.
Does that make sense to everybody? I think that's a really good way to think about this one. So it's almost like you've done a double estimation, right? You're just looking at this and saying, well, look, I mean, these numbers are close to other numbers that would have zeros at the end, right? So if we did something like, hang on, I want to fix a couple things. Let's use an approximation symbol. If we change the 12 to a 10 approximately and change the 78 to an 80, we can actually take a look at this and say, oh, look, then I'm able to reduce the zeros, like you said. So yeah, I think this is a really good approximation for this particular one, and it's not on the list that I just gave you, right? It's okay. Taking a look at this, though, the next question we're asked is your estimate high or is it low? Any idea about how we might make that decision in a convenient way that maybe doesn't involve a calculator? Did I just blow all of your ideas out of the water? Convenient without a calculator. And obviously, we could compare it doing like cross multiplication. That's not very convenient. That's kind of what I want to say. That's not really what I was going for. And obviously, you could sort of put it in your calculator and turn it into a decimal and do some sort of a evaluation with your calculator on a decimal approach. And that's okay too. But again, that's sort of relying on something that's outside of perhaps what your kids would be working with in your classroom.
See, the lower the number on top and the higher number at the bottom means it's a lower fraction.
Okay, this is what the ideas of what you're describing is exactly what I was going for. So let's do one piece of it at a time. Let's just consider changing the numerator only, okay? Ignore the fact that we changed the denominator from the numerator. Just change the numerator only. What did we do to our numerator? We actually made it smaller. So if you make a numerator smaller, what's going to happen to the fraction? The fraction becomes smaller. Make sense? Yeah. Make the numerator smaller, the fraction becomes smaller. Okay, now let's ignore the numerator. Let's think about the denominator. What did we do to the denominator? We made it bigger. What happens when you make a denominator bigger? Fraction gets smaller as well. So just considering those two pieces separately, both changes that we made the fraction smaller. This fraction is smaller than the one we started with. So since our fraction is smaller than what we dealt with, than what we started with, is our estimate high or is it low? It's a low estimate, because our value that we're using as our estimation is smaller than the one we started with, so our estimate is a low estimate. Something to keep in mind. So if we change this number into 1/8, and we said, okay, now I'm going to do some sort of calculation with it, we know that the calculation that we get at the end is a little bit smaller than what our answer really should be. Okay? All right, take a look at part B. There's a couple of things you might do on this particular one. So give me some ideas. What might you think you might do?
Could round denominator and then just reduce it.
Okay, we could do that. So what would you round your denominator to? Yeah, so we could take a look at this and say, okay, I'm just going to go with 2 over 1,000, and then I can reduce that to 1 over 500. So if we really want to keep a fraction involved, 1 over 500 is a reasonable fraction to keep involved here. Would the estimate be high or low? It's high this time. Why? The denominator is the only thing we changed. We only changed one thing. The denominator, and the denominator got smaller. So if the denominator got smaller, then the fraction got bigger. So this is a high estimate. There's one other thing that you might look at this and actually do, based on what kind of a problem you were working with. Any thoughts? You might actually say that this is practically 0. I mean, really, 1 over 500? It's a very, very small number. So it would be reasonable, especially if you were given a list of, which one's the best estimate kind of things. You might actually say this is practically 0. And then, of course, if you go with 0, that would be a low estimate. So it depends on what you would be doing with that estimate next as to which one you might use or how the question's worded. Okay? Any questions on those? All right.